I love running this company. I love running it because of the people I deal with. There's such a great team of people.
From a career perspective, it's the best move I ever did. I'm enjoying the work. I'm currently on a project and booked for another project soon.
It's given me the opportunity to work with lots of different types of technology and explore some stuff that I maybe only dabbled in at university or before.
SSW is a company that makes enterprise software solutions, and that's what we do. We build software for clients on demand. We build bespoke solutions using the latest technology and the latest best practices.
I've been involved in the development of some mining software, been involved in the development of software for a legal firm, and everything in between there. Even in just under 2 years, I've been working across so many different projects.
We play as hard as we work. You know, it's just a really great place to come into, and I always look forward to coming to work.
So since I've been working here, I've really been pushed, and that's what I wanted. You come to a place where you're working with a team of just absolute weapons. We've got the best in the business here, and that's an exciting place to be.
The guys are very passionate about doing things right the first time. We share our best practices with the community and with our clients and with others. Using conferences, we speak at events, and also we have the SSW rules, which is a huge archive of the best way to do everything.
The management here is totally approachable. So if you have a better way of doing it, or you know of a better method, then everything is up for discussion. As an example, say authentication. So a lot of the guys are building authentication into their apps, and they've been through many different ways of doing that. So generally what ends up happening or coming from that is a discussion around what's the best way of doing it. And we come to a decision based on industry best practice, as well as our own experiences on what the best method and approach is. And that then turns into a rule that we have on our rules.ssw.com.au website.
What really defines this company and make it work is the fact that we have people that are able to share their knowledge and solve complex problems together. It's a wide variety of different clients, different structures, different sizes, different industries, and different technologies as well.
The world we live in now is just so many light years above the world that we were working with even 5 years ago. We get into lots of topics deeply, and it's fascinating how it all works and why it works. You know, we get paid to make fancy jigsaw puzzles.
Access granted.
Developing software is a unique opportunity to be creative and technical at the same time. It gives you the opportunity to solve problems. It gives you the opportunity to exercise and flex your mental muscles by solving problems and figuring things out, while also being creative.
You can feel that energy when you come into the office. There's a really good vibe and connection between everybody who works together here. It's really collaborative, and we even have the tools for doing that collaboration now as well through Microsoft Teams. We always try and team up in pairs where possible for client work. 2 heads are always better than 1.
I believe being a developer, a good developer, is writing good quality code. But being a great consultant, which we are at SSW, is half-half between technical skills and communication. That's what makes us different on the market. That's what gives us our edge, because we're capable of not only doing great work in terms of technical skills, but also bringing value and bringing our insight based on our experience, saying, oh, to solve this problem, I would recommend you going that way or this way. And bringing that value, that strategic value to a client, and being able to phrase it, not only having it in your head, but phrasing it to give them options.
And we make sure that people are communicating internally with each other in a way that is professional and succinct, and we make sure that that's the way that we communicate with our customers as well.
And I want to show you a few ways that make email more useful.
People that want to improve their communication through public speaking can do that through the conferences that we're involved in. They can do it through SSW TV.
You might actually not need to go native, guys.
We have a lot of videos that kind of help get your face out there, to get your name out there. We also have a really good social media presence. We have a great marketing team that takes care of that.
We are client-facing all the time. There's no way to work at SSW and just be behind the desk and not talk to anyone. Every day you have to communicate. So that brings communication as a core skill of what you become. And some people develop it a way further, like by doing public speaking. We have awesome speakers. I think NDC videos prove that. We have awesome tech tips and even conferences given by SSW people. I think we had like 6 or 7 this year, so that's pretty huge.
One of the exciting things about working here is we're always on the bleeding edge of technology. We're always trying to reach out to those new projects. What are other people doing? What's the next best thing? I think Adam being a Microsoft Regional Director really gives us a bit of an edge in that regard as well, because he usually knows what's in the pipeline before other people do.
We've had many younger guys come through SSW, and in a few short years, they've become absolutely amazing developers.
You can have guys with just a few years of experience and they're building software that's affecting tens of thousands of users with some guidance of the software architects. It just works. It's amazing. You build something and you test it that you can enter an order, and then all of a sudden you can enter thousands of orders in seconds. It's just incredible. We couldn't do that a few years ago.
We have a couple of different ways that we socialise. Every lunchtime, we're killing each other in board games, which is always good.
It's interesting because those games, are about psychology. That's very interesting. You learn a lot about people.
The most exciting thing that we do is obviously our company retreats. We go away for a weekend after doing a brainstorming session. On the Friday, we all work together as a group and work out, problems for the company itself. We always try and keep the activities a little bit different to make it a bit of fun.
It's just a great weekend all around.
The people that come to work here want to be at that level of globally recognized expertise that some of the best guys at SSW are at. And even if you're not at that stage now, I think that a lot of people that come to work here are inspired by that.
A lot of clients come to us with maybe a general idea of what they want. And you can use your expertise and past experience to really inform their decisions and make sure that they're developing the best possible product. I really enjoy that part of it. I think that would be very satisfying for anyone who's been working on maintaining an old piece of software or maintaining an old system. If they could come and maybe work on some new greenfields projects and potentially influence the way that product comes out at the other end.
You can come up with cool designs, you can come up with new solutions, you can come up with elegant ways of solving problems that haven't really been done before, and plus you get to build something. And often the projects that we're engaged with, you get to build something that's going to make a difference.
People want more stuff automated, they want richer interfaces, they want bot interfaces. The architecture keeps expanding, the knowledge of Azure keeps growing. I'm still learning. I'm still trying to get better. I'm still trying to make solutions quicker, more maintainable, cheaper, and there's a long way to go.
morning, everyone.
Yeah, money. Go free! Go John! I feel like Adam's like true competitive personality only comes out on retreats. Like we go on a bushwalk, or we play tennis, or we go swimming, or we go go-karting, and all of a sudden he's just like, get out of the way!
Thank you very much for coming in, guys. I hope you all enjoyed your rides today, and I hope we see you all again, guys.
To SSW.
Coming up this month, major moves in AI as Microsoft acquires Inflection AI. .NET 7 is dead already, and Twitter learns that find and replace is a very bad idea. I'm Adam Kogan, let's get into it. G'day team, Adam Kogan here for the tech news for April. And we have a great session coming up. You can see it here, Cloud Native Aspirations with .NET Aspire. And we have two presenters. And the two presenters, you can scroll down here and have a look who they are. Matt Wicks, a super keen GitHub guy. He's a big DevOps guy. And also we have Rob Pearson. So Rob Pearson is one of the main men behind Octopus Deploy, and these two are doing a joint session where they're going to talk about .NET 8 and its role in cloud-native application development. Essentially, putting a Kubernetes, microservice configuration was very difficult on your machine. So they talk about this, how you can set up a multi-platform setup, addressing orchestration, service integration, and telemetry. You'll learn that .NET 8 and Aspire are very, very cool, and it's the best way to do a distributed app. So let's get into what happened this month. Well, I had a bit of fun at the beginning of the month. I did this, you can have a look at it. But essentially, I told all the developers that we are switching to Slack from Teams. Way too many believed it. Even our poor sysadmin believed it. It was quite a bit of fun. Now, on to real news. Real news, the United Nations have started trying to get a handle on artificial intelligence and why it's scary. I guess that's what they're focusing on. They're probably very, very old and not really up to date, but they're aware that this is going to potentially cause some problems, and I hope that they're going to be stopping deep fakes, especially if we can't trust a video, we're going to be in all sorts of dramas. It's not going to be good. It should be as illegal as counterfeit money, so we'll see. Now, this was huge news. This article, it's a bit rough. Microsoft reuses its OpenAI playbook. Well, it actually didn't execute this one, but they executed it on Inflection. In this case, Microsoft bought a whole bunch of developers. And this is Inflection, which is Pi, which is an alternative to OpenAI. It's if you want to try it out, I just was playing with it. You can have conversations, you can learn a lot of stuff. It's definitely worth trying. Have a look at it. The main man behind it is Mustafa Silliman, and they have him and a whole bunch of other people in a org, Microsoft AI, and he is now the CEO of that. So he has a very cool title and a very cool job, and he has all his colleagues that he was working with, and so we will see if we'll see what becomes of this, but it's certainly big news. He's also leading Copilot. Where are they going to be all working? Well, do we know? Well, we do now, because we now have the Microsoft AI Hub, a new office in London, and it is going to have a lot of cool people working there. They are going to be building a lot of AI over there, so that should be great. Next piece of news. This is a scary one, a huge vulnerability. You can look down here and read about this nasty vulnerability where they can do a DDoS attack. If you look at what it affects down here, it impacts a whole series of different things, but the thing that you'll probably care about is Node.js. If that's running, if you're in charge of a server running that, you better update it. So you better probably uninstall Node.js and then install the most recent version of Node.js. That is what you should do. That kind of indicates subtly that there's problems and you better install it. All right, next piece of news. Adobe is buying videos to train its AI engine. Is it paying enough? Well, it's paying $3 a minute to get its text to video AI generator. Now, you know when we see these cool things coming out like Sora from OpenAI or Luminaire from Google? Well, that's all great news for us, but people at Adobe get a big fright when that comes out. So they are going to be purchasing a ton of videos, paying a lot of money. I don't think that Google and OpenAI were paying for their videos. So that might be a difference. Anyway, they're paying a lot of money for a whole lot of video content from videographers and YouTubers, etc. Next piece of news, Grok 1.5. Well, this is Elon Musk's AI engine. Very good at maths, very good at coding. And if you use it, you're a Elon Musk fanboy. Right. So next one from GitHub. This is very cool. We have a new term. Found means fixed. So they've got this code scanning auto fix tool. So if you do a pull request, it will put a little suggestion in there for you to take the security thing that it saw that was wrong, and you'll get a very nice experience. In fact, they have a little video down here. We could play this. Let's have a look.
Code security scanning tools help us identify vulnerabilities in our code. But to remediate issues, we must triage alerts, review the relevant documentation, and propose a fix, taking up precious development time. That was until code scanning autofix. Autofix improves the experience by using AI to provide a code suggestion and explanation directly in the pull request. The developer remains in control, being able to make edits using GitHub code spaces or their local machine, accept the original suggestion, or dismiss it entirely. With autofix, code security alerts transition from being found to being fixed.
Okay, isn't that nice? And a very nice, quick educator, rather than doing a pull request, getting accepted by some other developer who didn't notice the problem, finding out about it a lot later. It's more like, I just did it and I just got corrected. So that's awesome. .NET 7, this seems very fast. We've just got into .NET 7 a little while ago, and it's already out of support this month or next month. So that is because you should be on .NET 8, and .NET 8 has what's called LTS, long-term support, and that was the .NET 7 story, and this is .NET 8. So this was announced a long time ago, but it's coming, into action now for us. I would say you should already be on .NET 8. We, as examples, this learning management system that we built called Sugar Learning, already running on .NET 8. This timesheeting system that we built, already running on .NET 8. So you've got it's a bit of an investment to get there. From 7 to 8 is an easy one. Next piece of news, running a large language model like OpenAI can be very expensive with a ton of calls. If you want to bring that cost down, you can use something like LlamaFile. We've had this for a little while, but this just got a whole lot easier. Rather than all the configuration, it's just like one file, you grab it, you put it on, and it talks about how it was harder and now it's quite easy. So you can just double click and now you have it. So be aware that kind of LLM on your in your environment is a much more efficient way in many cases than just thousands and thousands of calls. All right, we like finishing with a little bit of fun, and Elon Musk botched something, or X botched something with a find and replace. I gotta tell you, I cannot tell you how many times I have wanted to do a find and replace and then hit replace all, but I don't. And even when someone's with me and I I keep clicking replace, replace, replace. They say hit replace all. No, I won't, because I don't know what damage it could do. I'd prefer to just click that another 50 times and know what I just, see the impact of what I'm doing, than have an unintended effect, which is exactly what happened to the poor dev that did this, and it ended up making it a pretty nasty impact. So there's a lot of things that have the word Twitter in them, and then they got replaced with X, and then they tried to undo it and cause some more troubles. So there's a bit of pain that went with that find and replace all. All right. Hopefully you enjoyed that. If I missed any news, throw a comment down there. We're always keen to learn. All this video and lots of other videos are up there, and you can have a look at that. I'm Adam Kogan, and I'll see you in the next one.
All right. Now with that Matthew McConaughey impersonation botched, we're here talking cloud native aspirations with .NET Aspire. My name's Matt Wicks. I'm an SSW Solution Architect. I've been doing .NET since version 2. Now it's not .NET Core version 2, it's .NET Framework version 2 when it was in beta, so when it was Windows only a long time. I'm got some GitHub certifications, and here are my socials. And I'm doing this presentation with Rob here.
So hello, my name is Rob Pearson, and I'm very similar to Matt. I'm a .NET developer, that's my background, and I've been writing code for over 20 years, but I've worked both in Canada and Australia, if you can hear my accent. And I've worked for a range of companies and industries. Now I'm a solutions engineer at Octopus Deploy. So Octopus is a great Australian company based out of Brisbane, but we've got a team all around Australia, New Zealand, and the rest of the world. I joined the team when they were quite small through to the growth, and I've had a fantastic time. I have my GitHub there, and I no longer have a blog, but my social and octopus.com you can go visit. But yeah, it's great to be here, and yeah, join Matt.
Thanks, Rob. So here at SSW, we've got this cool rewards app, which has the ability to earn some swag. It even has some AI built in. So you can go and do some quizzes and earn some points, get some swag. I think we give away like Mi bands, and there's a really cool like USB charger cable that was on there. And when you plug it in, it says what the wattage of the how much power is going through and the wattage. It's pretty cool. So there's a QR code, so you can download that. So we've structured our talk today to talk a little bit about the history, so what led to .NET Aspire. We're going to talk about what is .NET Aspire. I've got a quick demo here where I'll take an application and add .NET Aspire to it to show how easy it is and what benefits you get out of it. And Rob's going to talk about some deployments. So deploying to a Kubernetes cluster, which is usually a bit scary. So let's start with the history. So .NET Aspire is kind of the culmination of a bunch of different technologies. It all really started in my mind when .NET became .NET Core and then eventually back to .NET because it went from a Windows-only ecosystem to multi-platform, which is really big. And the performance went through the roof. And the team has got this performance is baked into the team, which is really cool. Then with .NET Core came the Kestrel engine. So it's a super fast web server that sits in front of your .NET code. You can't have an application these days without proper health checks. This is now baked into the system, and Aspire actually takes advantage of a lot of the stuff, which is really cool. If you're doing any ASP.NET Core stuff at the moment, you should be really using the Zabrel health check tools. It's Zabrel starting with an X. They're kind of indispensable nowadays. When you're doing an API, odds are you're going to make calls to external services. Now, the .NET team saw that people weren't doing this in the most efficient way and having memory problems, so they made it easier to fall what's into what's called the pit of success. So they introduced an HTTP client factory. The reason being, HTTP clients are iDisposable, and everyone's been taught that when you're finished with an iDisposable, you dispose of it. That's the case except the HTTP client, because it is very expensive to warm up and you should be reusing it. The HTTP client factory helps you do that. And the other cool thing is that there's an open source project out there called Poly. Now, Poly helps you add resiliency and other things to your HTTP calls. And again, Aspire builds on top of that. gRPC, super important nowadays, especially with microservices. So having that fast communication between your different endpoints is awesome. Aspire makes use of that under the hood. And also you can use this in your ASP.NET Core apps. YARP. If you're not sure what that is, it's not like YAML, but YARP is yet another reverse proxy. So this is something that you'd experience when doing like a .NET 8 migration. You generally throw a reverse proxy in front of it with YARP and point off to your old app and slowly migrate bits over. Well, YARP is used inside Aspire to help deal with situations where you're spinning up a container or something or a service under the hood, and you can assign it a random port, but then have a predictable port, on your local desktop. Project Tie was a really cool experiment that helped, build up the YAML required to run, containers not in specifically Kubernetes, but to run a whole bunch of containers together. Now that experiment was finished, and there's an issue pinned on that repository, and it essentially says, don't look at this thing, look at Aspire. So it's graduated, and Aspire has taken over and run forward with that. Did you know that you can build containers? You can build images with your .NET projects. You can even say .NET publish, I want to output a container image, and it can. Now this is really cool. The best bit is you don't have to touch a Docker file if you're doing a .NET project. They've got a base image that is slimmed down and really performant, and the whole concept of containers in the .NET story is tied in with Aspire as well. And finally, native AOT. So if you are looking for that, that tweak out that last little bit of performance, there are some features in .NET 8 that you can use to improve your experience with AOT. So I just mentioned a whole bunch of different tools and pieces that you can use, but now it's not just I've got the choice between a whole bunch of Lego bricks. I've got too many Lego bricks, to choose from. I'm not sure which ones to use, and I don't even know if I'm going to put them together properly. There's a whole bunch of tools there. The next thing is, if I'm learning as a developer, there's a developer roadmap that you got to go through, and you've got everyone on the team now needs to be an expert in networking, containers, telemetry, networking systems, this, that, the other. It used to be easy, but now there's so many tools, it's hard to actually keep abreast of it, and essentially it just slows everything down. And they've done studies, and 60% of the time, all the stuff works together every time. Nothing works together by default. It's pretty hard, especially when you plug in a new piece, something else breaks. It's not a good situation. And unlike drawing an owl, building applications, let alone distributed applications, it's hard to do. So let's say you know what pieces to put together, you've put something together, someone joins your team. Now, Microsoft asked the community, and they came back with a whole bunch of questions that, general questions that people ask when they're joining a new project. How do I get my solution up and running? I want to run some end-to-end scenarios on it. I want to test it. I want to do stuff. How do I get it up and running? What was the port for the front end again? I forget, like Angular's default 4200, React is, Next has a different default port to Remix. There are too many ports. How do we set up monitoring on our project? Which one do we use? Do we use CloudWatch? Do we use App Insights? Do we use New Relic? How do I set secrets and options in my project? Do I set environments? Do I modify config files? What's the story there? I've built this and it works on my machine. will it work on the cloud? Super important thing to know. How do I set up resiliency policies? Like okay, there's Poly and I can configure it in my app, but does that mean when I use a package that may make an HTTP call, does that reuse my existing resiliency policies, or what's the story there? I've got a cache. I need to run Redis. Do I run a Redis instance in the cloud? Do I run it locally? How do I run it locally? I'm not sure. What about auth? And how do I do this? What about that? There's a whole bunch of different things that you still need to work out. And this is where .NET Aspire kind of comes in. So let's talk about what is .NET Aspire. So Aspire is a stack that helps you become more productive, especially when making distributed applications and cloud-native applications. But it can be used to build just about anything. So if you're building an application and you're deploying like more than one thing, so like a web app and a database, this is going to be useful to you. With .NET Aspire, you get orchestration. So you have the ability, it provides features to describe and connect multiple projects together and their dependencies, so in your local dev environment. There are components. Now, components are just NuGet packages, but what they do, tell all the different, they wire up all the different things coming from what's called an app host, so from the orchestrator, so that you can inject all your different secrets and connection strings and things like that into your projects. And they're just like wrapper libraries around, kind of like wrapper libraries around existing things that you'd use. There's telemetry in the application. So open telemetry is baked into .NET Aspire, and you get a lot of this outside of, when you get your telemetry outside of coming out of your different applications. So all your all your different services in your applications. What does that mean? Well, you get this nice dashboard that collects all the information, but then you can push that information to your App Insights or CloudWatch or whatever. And there's a whole bunch of tooling baked in. So there's project templates and tooling experiences to help you work in like the .NET CLI, in Visual Studio or Rider or anything like that. And it'll help you work with and interact with your different .NET apps and have a really good debugging experience. So let's have a quick look at the orchestration side of things. This is all based around app composition. So you can specify the different projects in your solution, the containers or the executables. So it doesn't have to be .NET. You can run a Ruby thing in there if you like, because you can run a container, you can run an executable. And you can even specify the different cloud resources. So if you do need to take a dependency on something like Azure Key Vault to pull in secrets, because you don't want them on the developer machines, you can. I talked about an app host before. Now there's an app host model in here. So there's a project that's part of your solution. And the convention is to suffix the name with .apphost, so you know exactly what it is. This isn't something that gets shipped to production. This is something that is only for local dev. And it helps codify your distributed application. There's a bunch of resources that you are codifying. So resources can be different parts of the application, like your projects, your containers, your executables, but also they could be cloud resources, like databases, caches, or some other cloud service. You wire the resources together via references. So you say that this resource will reference this other resource, and through that, Aspire can pass like a connection string out of a database resource and put it into a web API resource. These are expressed as dependencies. So this is what a simple app host looks like. There's actually a simpler one, which I'll show you in a sec, but let's just break this down in terms of the code that's happening here. You've got your top line, which I'm going to build a distributed application. So give me a builder. And at the end, we'll say, hey, build it and run it. We're going to say, hey, builder, add a Redis into the mix. And we're going to give it the ID cache. We're going to get a reference to that cache, so we can reuse it later. So it's just like a variable. Well, it is a variable. Next, we're going to add a project into the mix. And you can see it's using the generic syntax. And if I go over here, you can, oops, sorry, there we go. We've got, there it's referencing projects.aspireapp.api service. So there's some magic, under the hood magic that happens there. And when you make a reference to a project, it creates this class, projects, and inside there it has a whole bunch of properties with the paths to the different projects in the solution. So you don't have to type in the relative path, which is really nice. And this one's being called API service. So like, where's my mouse? There. This name here is actually really important because it identifies the service. So if we make a reference to it somewhere else, it can use service discovery. So when we want to call it, we say, hey, call HTTP API service, and under the hood, Aspire will know where to actually redirect that request. Next, we're building a web, and that's called web frontend. So that's going to have some references to our cache and to our API service. So we've essentially got that talks to a cache and an API service, and this is all codified. It's pretty easy to understand. Anyone think this is nice? Yeah? Who'd prefer to see it as YAML? Hands go down. All right. How does this look visually? Well, this is kind of how it is. It's this exact same thing. We've got an API project, an app host project up here. Inside there, we've got a container resource, which is our cache. And you can see it outputs a connection string so other people can talk to it. We've got an API service, and that has a service binding. And then we have our web front end, and that has a couple of dependencies we can see there with the arrows. So it points to the service binding and the connection string. Now, this is all really cool. And just under the hood, what happens is all these different things are resources. And of course, there's an interface to resource. So there's an iResource. But then there's some specialized versions that help Aspire know what to expect out of that resource. So what do you export so I can inject into anything that depends on you? There's resource with arguments. So that could be command line arguments because it's an executable, or it's a container that I need to provide stuff for. It could be a resource with a connection string, like a SQL Server or a Postgres or a Seek for your telemetry. But once that resource is spun up, you've got a connection string, so you know how to connect. You will know how to connect to it. A resource with endpoints, so like that could be a Cosmos DB, because you've got an endpoint that you make HTTP calls to under, it's got a RESTful interface. A resource with environment. So this environment is only to be, worked with on, this resource, you should only use it on certain environments, or it's got a configuration for a certain environment. So you want to do something different on staging versus prod. Resource with parent. Now that sounds a bit weird when it's parent of T. So that could actually be a database, because a database resource actually needs a server to run on. So the database is a resource with a parent of whatever type of server it needs. And finally, got resource with service discovery. So that could be a Node app running in the mix, because you'll need to know how to call to it, and that exports the service discovery information. There's a whole bunch of cloud agnostic services, resources that you can use. So there's a list here, and you can see there's things like MySQL, there's Node.js, there's Oracle, SQL servers in the mix as well. There's a bunch of Azure-specific ones. So these are services running on Azure that you wouldn't find on like AWS or something like that. So you'll notice that a couple of them, like Postgres or SQL, they've got Azure-specific variants. So any configuration that you want to do on Azure specifically, there's some wrappers for it, and you can use that. The cool kind of things here are like Key Vault, so you can pull in secrets from there. And cognitive services are on there as well. So that's like your OpenAI stuff. It's pretty cool. And a lot of it, there's a whole bunch of NuGet packages that you can pull into your project and use them. And the other cool thing about the Azure-specific resources is where the components are designed to connect to the Azure services in a passwordless fashion. So they try to use RBAC by default, and again, it's falling into that pit of success. The other thing you can do with Azure is use Bicep. So Bicep is a nicer version of ARM. It's ARM under the hood, but so there's a bit of a pun there. But it's your infrastructure as code for Azure. And the cool thing is that you can go add Bicep template and actually make a reference to a template in your repo or a NuGet package, or you can say add Bicep template string and actually put the long string in there. And the reason I think this is cool is that you could have your private NuGet server in your organization, and you've got a whole bunch of NuGet packages in there. So like, this is how we deploy a SQL server. This is how we deploy a web app. And we got version 1, and Project 1 is using version 1. Project 2 comes along, they use version 1. But then we update, we've got version 2, and Project 3 uses version 2. And I want to go and do an audit on all the different applications in my organization and find out if they're all up to standard. It's really easy for me to discover this when looking at the different references in code from NuGet feeds and whatnot, because I can either look at my NuGet server, or I can do a static analysis over my different repos and pull this information out, as opposed to going into the individual projects and working out whether or not they conform. So I find this really cool. And if Azure's not your thing, the .NET team got in contact with the AWS team before they even announced .NET Aspire publicly, and they said, "Hey, look, we're building this thing. Do you want to build your own hooks into AWS?" And they're building stuff, which is awesome. And in the preview that shipped last week, that lit up some bits, so you can do some deployments there, which is cool. And that uses CloudFormation under the hood, which is awesome. So I've talked about some service discovery pieces, and networking is big in Aspire because you're running a whole bunch of services. How do they talk to each other? So let's just go under the surface and see how the sausage is made. So when I spin up that application that had there was a web front end, the API, and the cache, Aspire goes in and it says, "Hey, look, your front end had a launch settings.json. That's kind of been there forever, in maybe not as a JSON file, as a different file, but it's got a port specified. Oh, and your API proxy has a port specified. So I'm going to respect that. You're going to spin up you want a Redis proxy as well? Okay, I'll give you a random port for that, because that could be anything. But these ports will kind of be consistent as you run. The next thing is, I'm going to spin up the actual instances. And my proxy, which is running YARP, will receive things on 5005, but then redirect to 65001. And that's where that instance of that front end will sit. The same thing for the API proxy, and then Redis, it'll spin up in Docker and go from there. And that's really cool, because YARP is abstracting that away from me. If I do have, if I've configured it to have multiple front ends, it will spin up all those things, and YARP will just communicate around. If I stop this, then what will happen is that front end will be killed, a new one will be spun up, and it'll just point off to there. So, well, not there, but the front end proxy will point off to the other thing. So I can stop and start and not worry about ports changing. But once this is all wired up, my browser can come in, it can call 5005, and then under the hood, my front end knows exactly, it's going to call 5006 and 65003 and hit the right things. YARP takes care of the rest. So there's a bunch of cool tech in there. So that's a really quick coverage of what is .NET Aspire. And I think the next best thing is to look at a demo to see, if I've got an app, how do I add that in? So I've got a couple of links here. I was lucky enough to do a workshop at NDC Sydney this year. And was it Scott Hanselman, Damien Edwards, and David Fowler from Microsoft were running it. And they had this .NET Presentations eShop app workshop. So it's kind of a trimmed down version of the eShop Web on Containers project, which I thought was really cool. Unfortunately, it was at Preview 3. So what I've done is I've forked it and I've updated it to Preview 5. So you can check out that fork there. When you run it, it kind of looks like this Northern Mountains adventure website where you get a whole bunch of cool things. I think that all the images are AI generated, but they still look cool. So it's a shopping website. And it kind of looks like this under the hood. So we've got a Redis cache, a couple of databases for products and orders, and then we've got a few APIs that we need to work with. But at the front, there's a Blazor front end and an identity server with Keycloak, which is really cool. We're not going to cover all of this because it's a lot of moving parts. What we will look at is kind of this slice here from Blazor all the way to a product DB, because it's just a nice vertical slice. So we need to get started with .NET Aspire. Now, there's 3 commands that you need to know to install it. The first one is .NET Workload Update. So I'm assuming you've got .NET 8 installed. I'd stick with .NET 8 at the moment and not look at 9, because what's happening is that the team is targeting .NET 8. And if you use 9, you'll most probably be on preview 3 of Aspire. They don't ship that version. They only ship a preview for .NET 9 when a new preview of .NET 9 ships. It's all automated. So they're targeting .NET 8. That's the safer bet at the moment. So it's shipped as a separate workload so it can ship outside of the .NET 8 servicing lifecycle. So do a workload update. Then say, hey, .NET workload, install Aspire. And then you say .NET workload list just to make sure it's installed. And if it's installed, it will look like this. So you'll see there's 8 preview 5 as my manifest, and that's come from the SDK of .NET 8. Awesome. So let's jump into some code and let's look at, we'll have a web API and we'll spin up a Postgres database. We'll connect the API to the database and we'll see how that makes life easier. We'll even hook in a front end. I'll throw that in for free. All right. So I'm using Rider at the moment. Now, like I said, you can use Visual Studio if you're on Windows, or you can use VS Code, works fine. Rider is awesome. The only thing that I'd recommend is go to the plugins and look for this .NET Aspire plugin. That lights up a whole bunch, all the features in Rider. It's really cool. So let's fire this up and see what happens. There's no Aspire, ripped Aspire all out of this. There's nothing there. If I hit play, that will compile and spin up, and we can see it's running and it's crapped itself straight away. Now it's essentially saying, hey, look, nothing's wired up. So nothing works. I've just joined this project. I need to wire some stuff up. So let's wire it up. I'll stop that and hide that away. And first thing I'll do is add in the app host. So I'll go here and add new project, and Rider picks up whatever projects are available, and there's a whole bunch of Aspire projects. And what I'm going to do is add in an eShop app host, because remember the convention was to suffix with .app host. I'm just going to make sure that the right app host project is selected, and I'll put it in the right directory because it should be in source. And it's complaining it already exists, which is awesome. So hopefully this is the demo fail for the night. I'll just fix that up. I'm just going into a directory on my side and just scrubbing it. Cool. There we go. Create. All right. It's done a bunch of stuff. Let's have a look. So this is the CS proj. It's pretty plain. I guess the thing that stands out is this prop here is Aspire host is set to true. And you can see it's imported aspire.hosting.apphost. And it's complaining. I've got in here, I've got a directory.packages.props just to set all the version numbers. And it's most probably complaining about that. So what I'm going to do is go in and scrub out all that version number. Cool. I'll go up over here and select app host, and we'll hit play. And you can see it's firing up some services, and there's the app host there. So this is some of the nice Aspire tooling in Rider. And if I click on this endpoint, you can see we've loaded up this eShop dashboard. Now, it's not listing any resources because, funnily enough, I haven't specified any. So I've got an empty app host file. It's that first step, like what I showed before, the top and last line. So it actually works. You can get Aspire going this quickly. This is a pretty slick interface. It's going to list out a whole bunch of different things. It's built with Blazor and using Fluent UI. So once you add .NET Aspire to your project, the next thing you do is go to LinkedIn, add Blazor to your skill set because you're using Blazor. Let's stop that, and let's add some stuff, and we'll see the dashboard in action. Now, this app host, like I said, isn't meant to be shipped to production. It's for local dev purposes. The first thing we're going to do is add in a database to this file. Now, I can't just add a database. I need to add one of the components. So what I'll do is go to, it's in presentation mode, so it's super big. I'll go here and I'll look for aspire.hosting.postgres, and that should pick it up. We've got a couple of different ones. There's hosting.postgres and hosting.azure.postgres. I'm just going to grab the first one and just make sure I grab Preview 5 and install that. Now that I've got that, I'm going to be able to add a database to the mix. So I'm going to go and create a Postgres by calling builder.addPostgres. There we go. Now I need to give it an identifier here. There's a whole bunch of different parameters I can give it. The first one I need is a name, not eShop on web. Copilot, you're going to stuff up my demos if I do that because I wasn't planning on all that. Let's do that. And just for fun, we'll even add in pgadmin so we can connect to it without running Azure Data Studio on here, because I'm not sure if I've got the plugins for that or how to actually, what the connection string is for anything like that. It's going to be a pain to manage. If we have a database server, we need a database. So we'll go var, we'll create a catalog, and that's pretty close Copilot, but it's not add catalog. It's add database. Sorry, Copilot has thrown me off again. It's postgres.addDatabase. You can't just add a database. It's with a parent. So you need to set it from the parent. And we'll call this catalog DB. Cool. Now that we've got that, let's just hit save and we'll run this again and see what happens. It's fired up. I'll flick over here and just refresh because it's the same port. And all of a sudden we've got some resources happening here. So we can see, it's a little tricky here, but we can see, hey, there's a container which is called Postgres, a container which is called Postgres pgadmin. And finally, there's a Postgres database in there. So it's detected that as a separate resource. We can see the state of them. They're all running, when they were started, what source they came from. So on these ones, it's actually pulled it in from containers, and we can see it's Postgres 16.2. So I think that's the latest. There's even endpoints there. So we have a TCP endpoint to connect to, and pgadmin's got a local host. So let's click on that. Bang, we're in pgadmin. I haven't configured anything, and it's here. And what's cool is that there's this Aspire instances. How the hell did it know that we're running an Aspire? Magic. Or it's abstracted away. So it knows pgadmin's a container, and being a good container, you can bind mount and have a configuration in there. You can pass in environment variables to configure it. And so the .NET team has baked in some of this cool stuff. So you get a nice user experience. I can see there's a Postgres database in there because I called the Postgres server, sorry. And inside there's the database. And that's being called Postgres as well. Did I actually call that Postgres? No, I called it catalog DB. Anyway, schemas. Yeah, So that's meant to be catalog DB. Anyway, we've got a database. That's the important thing. And we can go in and run some queries if we need to. I'll close that and just go back here. What else can we see? Well, we can look at the consoles for different resources. So I can see here's Postgres, and I can see all the server logs as if I was running them as Docker containers. Does anyone know the Docker commands to set all this stuff up? No? Does anyone know how the Docker Compose commands? We've got some things we most probably use Docker Compose. One person knows Docker Compose, cool. Two, you should put your hands up anyway if you're using Copilot, because Copilot most probably can guess most of the stuff. But then managing all the different ports for this is going to be a nightmare, especially once we start adding in new services. Not only do we have some console logs, we can look at some structured logs. There's nothing right now, but what I'm going to do soon is add in a way to seed the database, and that will fire some commands that we'll look at. We've got some metrics for resources that aren't showing up yet because they're not. Nothing's happening. I'll show you the rest of the stuff in. Oh, look, I'll show you this one. So the catalog DB, I can view some. There's no endpoint on that one. On the database, so we can see some stuff. So I've clicked on View Details. We can see some things about the container that's being run, the ports that it's exposing. There's endpoints. And we can even go down and see the environment variables being injected into that container. So this is all happening out of the box. I didn't have to do anything. But if we can do this for this one, we can do it for stuff that we run and inject our own things, which is pretty cool. So we've covered that off. Let's add in that second Postgres package actually, because I thought that was cool. I'll go in and go to Manage NuGet Packages, and it's still here, so I don't have to search for it. I'll just add it into the mix. And so this is aspire.hosting.azure.postgres. So as the name suggests, you're setting up Postgres, but it's got Azure in there. So how do we add Postgres on Azure? Well, Azure's got some cool services, and Postgres was one of them. So I can actually go in and say, hey, publish as Azure Postgres Flexible Server. So when I go to publish this, it knows that you'll want to spin up an Azure Postgres. It's pretty cool. And I'm describing this here, so I know kind of what my end state is going to look like when I'm building this out. I'm not going to deploy this, but what I'll do is start looking at spinning some stuff up. But I just wanted to show that, hey, there's, you're publishing, how you're describing how things are published, you can bake into your app host as well. All right, well, we've got our catalog DB. What we'll do now is add in an API. Well, we'll add in our DB manager, which seeds our database, and we'll add in a catalog API so we can query stuff out of that database. We'll start off with seeding it first. Now, I've got this catalog data manager here, and yeah, it's that variable's never used, that's fine. What I'm going to do is add a reference. Now, I'll add a reference. I know I'm going to do data manager, and I'm knowing I'm going to do API. I'm not going to add it to data because that's something that gets reused, but these are my entry points. I'll add those in. And now what I'm going to do is say, hey, builder, add a project. Now, I can say projects dot, and all of a sudden, I've got some some IntelliSense here saying, hey, do you want to add a data manager or an API? How the hell did that work? Well, I can command or control click on data manager, and you can see there's an auto-generated class here. It's got a data manager. It implements a project metadata interface, so Aspire knows how to find it. And then it's got some project paths. And you can see it's only got the data manager in there. But I imported 2 projects. So there's a bit of, not magic, but there's some cool stuff happening under the hood. So in our app host file, because it is an app host, when you make project references in here, it knows to do some, not compilation, but like some runtime stuff, and it can add these things in as you use them, which is really cool. So I don't need to remember the relative path. it takes care of it for me. And that way, if I move some things around, as long as the references aren't broken, it'll just work. If I break a reference, I'm going to get a compilation error, which is actually really good, because that's usually compilation error helps you find bugs. So we need to give this thing a name. So I'm going to call it the catalog DB manager. I'll save some keystrokes because you only get so many in your life. And I need to add a reference because I need to connect to my catalog DB. Now, this will spin up the manager and whatever things the catalog DB output, which will be the how to connect to it, will be injected into the data manager project when we spin it up. Let's fire that bit up just so we can see what's happening. I'll go here. I'll just hit refresh. Cool. Now it's bombed out because just because I inject some stuff, I add it to Aspire, doesn't mean it's going to work out of the box. I still need to go into my project and add a couple of settings. But what I'll do is I'll just go into the details for this catalog DB manager, and we can see it's got the there. And if we scroll down, it knows it's an ASP.NET Core thing because it's in the launch settings, so it's injecting the environment. And we can see here there's a connection strings, catalog DB. And there's our connection string. It's got a randomly generated password. I don't have to know about it. I don't need to know the ports of the local host or anything. Aspire's taking care of this for me. So let's, now that the right things are being injected into it, let's upgrade our catalog DB manager so that it can seed the database. Go back here, close that. Now, what we're going to do is have a look at catalog.data.manager. It's obviously using Postgres, and it's using Entity Framework Core, which is awesome. Now, we just need a component that makes a reference to this project and adds and wires up all Entity Framework Core for us. And the really cool thing is all we have to do is change the project name and just add Aspire dot to the front. And they're reusing, the components all reuse existing NuGet packages that you most probably use. If we do that, that will wire up Aspire for us. And so it knows where, well, it half wires up Aspire for us, but it knows where to grab the right things. Now, the next thing we'll have to do is go into our program, and I'm not going to copy paste. I'm just going to comment on comment because it's a lot of code to write. But previously we had add DB context using Entity Framework. That's fine. We've got a replacement one, which has a slightly different method that we call, and that's add, Postgres DB context. So it's just specific to that, and that comes from our Aspire components. Now that we've got that, let's run it and see what happens. I'll just restart this, stop and rerun. Cool, that's running. If I look at the logs for that project, you can see a whole bunch of insert statements. So it's watching the logs, and that database is being seeded. If I go to structured, it didn't find any structured logs. It's not finding anything. It's not finding any telemetry, but Aspire is meant to have telemetry out of the box. It does, but again, you need to wire it up. Now, the other cool thing with Aspire is a thing that it has called the service defaults project. What you can do with that is, well, let's add it in, and I'll show you what it does. So I'll have eshop.service-defaults. I'll chuck that in source directory and just make sure it's the service defaults project. All right. So this project has as a class in there for extensions. And what you do is, as part of your app bootstrap, you add the service defaults. So every project should make reference to the service defaults so that they're all configured the same way. And that configures OpenTelemetry. It adds health checks. It adds service discovery. It configures an HTTP client with a standard resilience handler from Poly. It configures the HTTP client to use service discovery. So if you're making calls to other apps as part of your app host, we'll know exactly where to point it to. For OpenTelemetry, it's got a whole bunch of same defaults, and you can export your OpenTelemetry as well to somewhere else. So there's some logger options. It's even got some stuff to export to Prometheus or Azure Monitor. So you can do a whole bunch of things with this. And there's some health checks out of the box, so it knows when things are healthy, so that dashboard works properly. So let's close that, and we'll go to our data manager, and I'll just add a reference to service defaults. Cool. Now that we've got the reference in service defaults, let's fire it up again. Oh, so here's a bit of a gotcha. OpenTelemetry has known moderate severity vulnerabilities in the ones out of the box. So the template uses some older versions, which aren't great. Thankfully, though, those things have been fixed. So, and I've, in my global version file, I reference all the right versions. So I'm just going to remove the versions from here, so I'm using consistent stuff. Fire that up again, and I won't get that error. All right, so that's running. We've got our console. We're still not getting anything, even though we added the service defaults. And that's going to be a little concerning because it hasn't been wired up 100% properly. So just because we have this in there doesn't mean we still have to call the methods. So top and tail, add service defaults, and we're mapping some default endpoints in there for health checks and whatnot. So let's add that in and rerun it. Now we've got some logs here. So you can see a whole bunch of stuff here, applying migration. There's a whole bunch of database commands. If we look at our traces, that doesn't look that great because I'd expect this to be a single trace. I'm just seeding a database. Well, it doesn't know that it needs to group group all these things together. It's all considered one main call. So what we can do is go into our data manager, and for this project, there is a migrate DB context, and there's a line to, you can add OpenTelemetry as a service, and for tracing, I want to lock it down to just the activity source name. I'll add that in, stop and rerun. I'll just reload this. Bang, now there's a single trace with 24 calls to the database manager. So we're starting to get the ability on our locally run apps to see what a single action from like a front end, in this case, the database manager, and that translates into 24 calls to dependencies. So I can go in here, I can see that, hey, migrating catalog DB context was called, it took half a second, and it ran all these queries. So that's really good, but I'm a little concerned that I'm reseeding the database every time. When I'm firing this up, it's actually making a container all the time. So if I go across, I'm using OrbStack here, and if I look, we've got Postgres and pgadmin running there, and at the end, it's putting like some random characters as a suffix, so that when I stop and start, it spins up a new container. I'm going to get brand new things. So if I go in and just press stop, flick back to OrbStack, bang, they disappear. So let's just make sure that we're persisting our database in between calls, in between stop and starts, so that if we did make some changes and we want to, restart it and keep those changes, they're persisted. Thankfully, there's a nice and easy method that we can call, and that's with data volume. And that's half of what you have to do to get a persistent database happening. If I do that and hit start, it will start up okay this time. And if I stop it and start it again, funnily enough, it craps out. And the reason being is that in the container, there's actually, in the database, it says that there's already a database in there, but the password changes every time. So the connection into the database breaks. So that's not a great experience. Thankfully, in order to fix it, we just stop. We'll go over here to our volumes, and you can see here there's a data volume here for our Postgres. I'm just going to delete that because we can't really reuse that. But what we can do is go in here, and we'll actually just set a user secret just for me. So I'll go .NET user secrets set, and I'm going to pass in a parameter. And now there's a convention to this parameter, and that's the resource name dash password. So it'll be Postgres, because I've called it here, Postgres. I could call it Big Server, and I'd have to call Big Server down here, but it's just a name. So we've got that, and I'm going to give it this super secure password because I'm using uppercase, lowercase, numbers, and exclamation marks. If this is your password, please change it. That's interesting. Oh, I'm not in. No, that's my bad. No, I'm in the right directory. .NET user secrets, set, parameters, Postgres, password. That's interesting. It's not liking that. I'm going to do it the other way. So I've got a tool here to help me access my user secrets in a slightly different way. It's Postgres-password. Close enough. I don't know if that's more secure. I highly doubt it. I've got a security expert here.
What?
Somewhere. Somewhere.
You wouldn't tell you if you want.
Yeah.
He's already crying.
He's already crying. Okay, well that started up, and it's running there. If I go into my traces, I can see it's still made a whole bunch of calls because that would have just seeded it. If I go and stop and start, that trace wasn't found because it's a new one, and now there's only 8 calls, so it's making fewer calls. It's most probably, for each of those 8 calls, it checks to see if something exists and then injects a bunch of stuff. But now that there's fewer calls on the startup, we know that the data is being persisted. I can go to this volume. I could even go into it and have a look. And on one of my screens, it would open up the, maybe I can't because it's being mounted at the moment. I'll just stop that. It's not actually letting me open it up. Anyway, there's a volume, it's bind mounted and being persisted, which is awesome. Okay, so we've got things persisted. We've grouped together our calls on that DB manager, which is awesome. Let's wire up our API. We already made a reference to it in our project, but we need to add it to the mix. Now, since we'll most probably use this API later on, I'm going to go, I'll call it a catalog API because it's better to have a slightly more descriptive name. Now I'm going to go builder.add project, and that's to projects dot, and then I've got my catalog API. I need to give it a name. I'm going to be super original and call it catalog API. Now we'll have to make a reference again to the catalog DB. Just going to rename that because I like consistent names. Awesome. Now, how is this catalog DB going to call our database? Well, we'll have to make similar modifications that we did to our database manager. So thankfully, I've done some of the code. I'll go to our API. We'll go to our program.cs, and we're going to have to wire up the service defaults, map some endpoints, and make a reference to our service defaults project to make that work. Cool. Now there's a few other things. We want to have some open API endpoints. We want to have an exception handler, and we want to wire things up consistently for open API. Now, these are all red at the moment. Now I've got some classes that I'm going to import to the service defaults instead of typing it all out, because it's not specific to Aspire, but know that when you're wiring up your APIs and you want to be consistent, you can put things in the service defaults and consistently apply them. So I'll go to our service defaults and I'll just add some existing items. And I've just got a few files to do some stuff. I'll just add links to them. Now, that's going to complain because I'm missing some references. Let me just get the references. Sorry, I've lost them on my screen. Give me a sec. So, sorry, I'm just going onto my repo because I've got them there. And I'm missing the notes on them, which really sucks. So we're adding in a bunch of stuff. There's some open API stuff, so a swashbuckle reference. There's also stuff for open API, and there's some auth ones as well. I'm not going to cover auth today because it's a little bit too much stuff to cover off. We're going to be going through quite a few things already. So if I go to where is it? Here. Sorry about this. I hate dead air, but I'm just going on my repo. I've got a history of me removing it, all the stuff, and then adding it back in. So I'll go. Why isn't it there? Catalog, cool. Why isn't that going there? Sorry, no, it was in service defaults. Source, service defaults, on commits, great. Okay, so in my service defaults project, I've got a whole bunch of things here, but what I want to have is a few more. I think those are the ones I want. Let me just check. I'll kill that one. No, I think that's the problem. I've included too many files. Okay, that's compiling now. Sorry, missing a few extensions. So I've added in the resilience into here, service defaults. I've added in service discovery and swashbuckle because I want to configure Open API. If I go back to my catalog API, this is all green now, which is awesome. Now that I've got that, again, I'll need to check out what things am I importing. Okay, that's running fine. But I've still got a similar thing in here where I'm interacting with the database. I need to make sure I'm using the Aspire version, not the Entity Framework version. So I'm going to comment that out and pull this one in. That's going to require me adding in the right package onto this one. So what I'm going to do is just steal it from the data manager and import our right package. There we go. Awesome. Now that that's in, I'll hit play. And I've got a duplicate package. Which one is duplicated? It's going to be one of these. Yes, resilience, I didn't need that. And I didn't need service discovery. I just needed swashbuckle. Let's run that again. Bang, we've compiled, we're running. And if I reload this under resources, we can see now that we've got our catalog API and that's got an endpoint. So I'm just going to go to that, click on that endpoint. I've got a Swagger interface come up straight away. And I can see that there's an endpoint about getting catalog items. I'm going to try this out. Page size, I don't want 0. I'll maybe get 5 items out of there. Hit execute. And we can see that some data's come back out of a database. So I've made a couple of changes in there so that it knows to pull in the Aspire stuff, and I've been able to pull some stuff out once I've added the right projects to my service defaults. Anyone think this is cool? Apart from the demo failure? Yeah? No, I don't want to search this. Cool. Let's close that. So we're returning data. Let's add in the web app and finish the story up. So this is, no, that's catalog API. Here we go. Here's our app host. We then want to go var. We'll have a web app, and that will be calling the builder again, and we'll add a project, and that's going to be projects dot. Oh, we need to add our web app. So I'll go to the app host dependencies, hit reference, pull in web app. Cool. Try that again. There's the web app. Awesome. Let's give it super descriptive name. And we're going to say, hey, look, with a reference to our catalog API now. All right. Now that we've done that, we've got to remember to go into our web app, and we're going to add a reference to our service defaults, because we need to remember to bring that in. In our program CS, I've got a few things to comment out. So there's the add service defaults. There's a default exception handler, so it's handled always the same way. And we're going to map our default endpoints. Awesome. Anything else we need to modify? Well, how does, let's try this out and see what happens first. There's most probably something else we need to modify. I'll go and fire this up. I'll close this window here and just refresh. Cool, we can see that there's a web app running right at the bottom, and there's an HTTP endpoint for it. I'll click on that. Ready for a new adventure. Seems to be loading stuff. Let's just make sure. Nope, there we go. Some cache had kicked in, and the images aren't loading. It's talking to the API. How do we know it's talking to the API? Well, when we look at the details on our web API and we scroll down, there's a whole bunch of different things. We can see here there's a whole bunch of OTel environment variables. That's the open telemetry exporter variables that are being injected in. We can also see down here, services, catalog API, HTTP0. I'll make that a bit bigger so you can see, because it's gotten small for some reason. And we can see it's put in the right address. So it's being injected with the API endpoint. This looks really funny that it's formatted this way, but it's done that by convention. So it's trying to be predictable so that when you do want to pull things out, you can say, hey, look, it's a service, it's a catalog API, and it's an HTTP endpoint. If I go over to my web app here, and under extensions, I've got some things hooked up here. And funnily enough, I have the right port there. Because if I had the wrong port, just by chance, it happens to be the right information. If I change the port number there, it'll obviously break, and there, it's stuck on loading. It's not loading, it's not working. So the better thing to do here is to actually change this from localhost and put in a port number, because we're hard coding this value in this place, is to actually go and change it to log, what do we call it, catalog API. We literally take that identifier here and reuse it here. Oh, it needs an I. And reload, and it's loading up data. So we were in a false sense of security before, but all these images aren't working. If I load up the dev tools and click on the image, we can see it's calling product images 99. Now there's no way for our API to know how to get the right image from our backend. Look, we can make calls and do stuff under the hood, or we can use a cool ASP.NET Core feature to forward requests to that endpoint to a server behind the scenes. So what was the format again? I forget. So it's product images / and then that looks like the ID of the image, because if I hover over it and click on it, it becomes item 99. I'll do it on this homepage because there's a few more things going on here. We'll be able to see it straight away. I'll stop the application, go back here, and what I'll do is I'll go back into our program CS, and after everything is wired up, I'm going to go app.map, add forwarder or something. This is the right one. So it's app.map forwarder. Cool. Then I can give it a regex, well, not a regex, but a pattern match. So I can say product, I could spell images / and then extract the ID out of there. And then what do I want to do? Well, I want to forward it to somewhere. I can see in the IntelliSense that it's saying, hey, the next thing is a pattern. We'll start with a pattern, which we supplied. Then it's a destination prefix. And then maybe if we go down a bit, there's a config transform, or like how do you want to map it to the right thing? So we know that it's to the, it's going to go to a catalog API. That's fine. But where in the catalog API? Well, if I look at the catalog API, there's a PIX directory, and funnily enough, they're all stored there. I mean, it's a proof of concept, a real life scenario. You wouldn't put a whole bunch of images in there like that. But the concept is fine, because what I can do is say, hey, catalog API, then there's actually an endpoint in there. I apologize. But it's under catalog /items, and then ID pick. Save that, put in a semicolon. Let's run that again, and we should be forwarding things from our web app API to grab the right picture. Hit refresh, bang, we've got our images, and just to make sure, I'll open this up and go empty cache and hard refresh. Yes. Okay. Who thought that was cool? Most of the people. Awesome. So this is, where's my slides here? So what did we do? We spun up a web API and a web app. We spun up a database, connected all the bits and pieces together, and we saw how .NET Aspire allowed us to hook some things up. Yes, we had to add some project references in there, but those project references allowed us to, hide away some of the stuff that we would be doing to kind of manage our local dev environment, so we can focus on writing business logic. If you like that dashboard, there's a link there in terms of how to grab it. It is a Docker container. You can grab it and run it by itself. You can run it in production. It's fine. All the data does get stored in memory, though. So you have to take into consideration, and there's a Docker command to run it, which is really cool. All right, so we've had a look at some of the demos. I'm going to pass over to Rob to look at deploying. Thank you, Rob.
All right, excellent. I've got my login screen. Just see if we come back together. And I need to just shuffle things to the other screen. Apologies, this one hasn't woken up. And try the other one. And there we go. All right, give me 1 second. There we go. So I'll pop this up. So Matt told the strong story of .NET Aspire, and it's this, I think, a pretty amazing technology, and it can save you a lot of time wiring things up and piecing all these different components together in a distributed application. And so building it, the kind of the build side, the development side, there's a lot of productivity improvements, and it's a lot of things that can improve how you work on your local machine, and that's great. But the other half of the story is when you build an app and you're writing code, you got to get it to your customers, and typically that's done by deployments. And so what I'm going to do is take a look at the deployment story. And one of the amazing things, like I think Microsoft and the team behind Aspire has done a really good job with the deployments, keeping it cloud agnostic. It's not just the Microsoft world, but it's flexible and open. And they're really playing really nicely in the modern ecosystem. You can use nice tooling, and like Matt's working on a Mac, I'm on a Mac, you can be on a Windows PC. All the tooling plays really, really nice, and all the artifacts are generated via CLIs, and you can have things that you leave in your repo. So it's a really, really nice story. So when you get into the deployment story, the first thing that you can see, and if you've seen any of the demos, they have like a seamless Azure story. So if you do .NET new Aspire template, you can get it into Aspire really, really quickly, and it's amazing. But the great thing is, it's not just Microsoft. So AWS has added support, and it's come in the latest preview. But again, if you're working with AWS, you can still take advantage of all these innovations and updates. But there's also something really interesting. So if you're working with AWS or Azure, that's great. But if you're like Octopus works with a lot of companies around the world, and we learn what they're deploying. And right now, like the traditional ones are virtual machines, and there's still tens and hundreds of thousands of them out there in the world. But a lot of teams are shifting to Kubernetes. It's shifting to cloud native. And so they may have elements that are cloud specific, but others are just shipping to clusters. It might be AKS, it might be EKS, etc. And so there's been a community project that spun up that is leveraging all the open, flexible, like kind of foundation of Aspire, and it's allowing you to deploy to Kubernetes. And that's kind of the magic of all this tooling and the openness and flexibility. And the great thing is the CI/CD, or the the deployment story is compatible with CI/CD tools. So it's not like the old days where if you saw a Microsoft demo, you right-click deploy from your local machine to production, and typically that's a very bad thing. So if you're using GitHub Actions, Azure DevOps, TeamCity, your tool of choice, Octopus, you can play nice with them. And at the heart of this, or kind of the keystone of Aspire deployments, is a file called manifest.json. And what that is, when Matt was going through the example and he had the nice diagram of all of the different parts of an Aspire application, resources and containers, as part of the build process, you can generate this manifest.json. Cloud tooling, the various tools generally just do it in memory, but you can generate it manually to actually get the file. But it is the key part of the flexibility, because it describes all those containers and resources and the various parameters that need to change when you do your deployments. And that allows the different tool makers to build on top of that. And so how do you do deployments? The first step really is to this foundational thing. A lot of times it's hidden, which is to generate your JSON manifest. Then you leverage cloud tooling to help you either generate some of the files to do your deployment or actually do it for you. And the third step, that's where you're winning, which is shipping real software to your customers. So, and working through an environment-based workflow. You might have dev test prod or dev staging prod, whatever suits. And so, as I mentioned, Azure deployments are beautiful. Out of the box, Aspire supports Azure Container Apps. And you can see just like a little snapshot of how that looks. But there's a handful of commands that make it easy to initialize and get your, even a starter application, into Azure incredibly easy. And in terms of demos, it's pure magic. Now, again, demos, it's typically not what you would be doing in the real world, getting things into production, but it can bootstrap the process, make it a lot more quicker for you, and allow you to iterate quickly. And so it leverages the Azure Developer CLI, AZD, and if you haven't had a look at that, it's pretty awesome. And there's a handful of commands here just to highlight. The init command just gets you bootstrapped, like just get up and running, understand your project. But once you've done that and you've logged in, authenticated with Azure, AZD up, and it will deploy your application. Well, it will provision all of the infrastructure required, and then do your build, push it to a container registry, and deploy. It's amazing. And just the 2 or 3 commands, and you're up and running. But then the thing that Microsoft has done really well is they also have AZD pipeline config. So that's the other side, that they're even playing nice with CI/CD pipelines. And out of the box, they support GitHub Actions and Azure DevOps, where it will create a default CI/CD pipeline for you. If your repo is not already source controlled, it can help you with that. But it pushes initial configuration values, if you've already done a deployment, into Azure, or sorry, GitHub Actions, etc. So it saves you a ton of time doing that. It all just works seamlessly. And then from that point, you can build on it. So Aspirate is a really interesting project as well. So if you look at the repo for Aspire, there were a lot of issues where people are asking, hey, this is great, but I don't deploy to Azure Container Apps. Can we deploy to AKS, Kubernetes clusters, etc.? And so there's somebody named David Sekula, and he spun up a project to do just that. And again, building on the open nature of everything, he's taking advantage of that manifest.json file, but he's built some tooling around it that allows you to generate customized files, or Docker Compose if you want, that allows you to deploy in a very standard and consistent way. And so something like that could help you if you're not just doing hello world, you're not spinning up a new project, but you're you're updating an existing one and shifting it to Aspire. And so just to the very end there, I've got the link, but if you search for aspirational manifests, that you'll find the repo. So let's jump in very quickly, and we're going to take a look at a handful of things. One, what is this manifest JSON file? And we'll see how does Aspirate work. And the real amazing thing, I think, in terms of deployments and leveraging Aspirate is you can deploy to a Kubernetes cluster locally. So it's a very similar experience to what your deployment will be when you deploy to production. So let's just jump in now. So first thing I'll do is I'll just go to Visual Studio Code, and similar to Matt, I like working in Rider, but just for simplicity, looking at this is my project directory. This is the hello world. This is the starter template. So it's kind of a weather app, etc. But looking at this, it's exactly what we were talking about. It's describing the resources and the parameters, describes the environment variables that allows you to deploy. These are the things that any tooling would require to get your application into an environment. And if you're working with AZD, it will populate a handful of files in your repo, which you can then commit. Some are hidden, so they aren't committed because they can be secrets. But this is an example of a handful of the configuration files that are generated after you do an init and an AZD up. And it's all captured here. And these are environment variables that AZD, the command line, would use to do a deployment. Those can then be leveraged if you're using GitHub Actions, etc., because you just override those same variables, and those will get picked up by the tooling. And so the other thing I'm looking at here, if I expand this just a bit, so this is my app host directory, and I've already run Aspirate here. So what you can see is a customized file, and you can see it for each of my containers, and it has the appropriate files, which is really nice. But if I jump to the command line just quickly, what we can see here, this is a raw project, like this is a command line. I haven't created a project yet. Apologies. So how do you get started? Just as a very simple example, this is just creating a brand new project. So it's just using the templates, brand new, and I'm using Redis, and I'm creating a sample project. If I go into the project just quickly, if we go AZD init, then what it does is it can just scan my existing directory. And that's how it figures out what you're doing and what's required to get this application deployed. So it found my Aspire application host, and then it understands what it needs to do, be able to do a deployment. So I say, yes, that's mine. And if I just gave it an environment name, just like demo dev, it generates more files. But from here, I could go AZD up. And AZD up runs AZD provision and then AZD deploy. And that, once you've logged into Azure, gets a brand new application configured into Azure running. And it's magic. So that's kind of the Azure story. The other side of things is, which I think I'm quite excited about, is Aspirate. So Aspirate here, it's, again, a command line tool, and it allows you to work off those same manifest files to be able to generate customized files to deploy to a Kubernetes cluster. So I've already done these commands, so you can see init, I've done the generation. It has a build step. That one I really like, because if you have this a part of your CI process, you can build and just push your containers to a container registry as a separate step, and even then split out the deployment. Maybe do it the way you currently do, or build that into your CI and make a CD process as well. But the nice thing is, if I went Aspirate, apply, because there is a secret, and this is similar to what we saw with Matt, I have a password here, so it builds in a secret generator into the file, or into the generated file. You go to apply or deploy, you have to use that same password. Here, I'm just deploying to my local cluster. I've already done it, so it goes through very quickly. But the really nice thing about that is a consistent deployment, same as I'm going to if I was deploying to an AKS cluster. It's deploying. I'm just deploying to my local one within Docker, but it's a really nice experience. And so the final thing I just wanted to highlight is, and I have to move this screen over, is how everything's open. Oh, apologies, I'm trying to drag it over. Wow. Yeah, it's on the, let me try and move it over. There we go. Okay, now if I'm here, I can at least go full screen. So it still plays nice with any other CI/CD tooling. This is Octopus Deploy. If you haven't ever seen it before, it's best in breed or continuous delivery, deployment and DevOps automation. So we have a dashboard here. What we can see is I have a project called Cloud Aspirations, and I've done a deployment to dev and staging. That was the last build that I had pushed. And my release was triggered after the registry push. Octopus can monitor external registries and then create releases based off that. But if I jump into this project, final thing that I wanted to do, there is one newer build that has been deployed, but what I want to do is I'm just going to deploy to production quickly. This is a deployment summary screen. You can schedule it or customize, but in this case, I'm just going to go to production. First thing it's going to do for this particular one is a production approval, and we're doing a demo, so we're happy to proceed. Now, this will go through and it's going to run a series of steps, and if you can see from the summary, it's updating database and a series of other steps. But I wanted to jump to the process just to highlight the open and interoperability of Aspire deployment. So again, this has an approval and a notification step. I've got a couple other deployment steps, but I want to look at this deploy with customize step. So this is UI driven, but this is a version controlled project so everything is stored in source control. But I'm pointing at all the output files that were generated by Aspirate. And so whether I'm deploying locally or externally using a separate tool, I can still use those files and deploy to a Kubernetes cluster. And what this allows you to do, you can use GitHub Actions, you can use Azure DevOps or your tool of choice, but Octopus provides good visibility into what you're doing, easy deployment configuration, and also it allows you to capture some variables. This is an example where I have two different subscriptions. So if I'm going through dev test prod, I can go to automatically use one subscription or another, etc., and capture all that here. But that aside, we'll just do a quick check, and our deployment was successful. So effectively, if I jump back to the slides, that's pretty much everything, or a good introduction to the deployment story. Seamless Azure support, AWS support has arrived, Aspirate is great, open flexible deployments to Kubernetes, and it's compatible with your tool of choice. Octopus is mine. And then there's a reference for all the steps for if using AZD or Aspirate, etc. So now I'll hand back over to Matt.
Thanks, Rob. So you've been able to deploy to Kubernetes, to Azure, to Kubernetes. If you're deploying on-prem, you'd be using Aspirate as well. So you'd run a Kubernetes cluster on-premise. That is the on-prem deployment story. So .NET Aspire. There's a link to the repo. It's a different to what I demoed today, but it is up to date, and you can have a look at that. It's got a few different things in there, like running a Node app and whatnot. It's pretty awesome. Preview 5 shipped a week ago to the day, which is awesome coming into a user group, and the new preview ships and all your code kind of breaks. Yeah, preview 6 should be interesting. I was watching the community stand up this morning, and they're talking about some cool things coming there. So the APIs are changing slightly. They're adding some more stuff. Some things have been marked as deprecated, but this is all going to settle down because the plan is to kind of go V1, I think American summer. So what's that, June? We're not far away. So hopefully around then we'll get a V1. But I think the short and long of it is it improves your developer experience now because it's that local dev story. If you're deploying more than one thing, like a web app and a database, there's gains to be made because eventually you're going to add more services, more databases, more stuff. So those are great to consider. I always like to think about that F5 experience. You know, you join a new project, it's stressful, you got to learn a new domain, but then you're working on a new code base. So you want it to be inviting and familiar, and you want to jump in and dive in and do stuff and feel like you're able to do things. And when you've got a README file, that's pretty good. You know, you've got some docs, but you know, when were the docs last updated? You're most probably going to be the guinea pig to test how up to date they are, and hopefully, if you're a good person, you'll be updating the docs as you go. And not just leaving that mess to someone else. I think, what is it, the scout rule, or, you know, leave it better than how you found it. So, you know, there's a README file. Maybe there's a script. Yes, you put in some more. I don't have to go and look at all these different places and pull things together. But who was the last person who wrote the script? Maybe they did it in some weird language, or they did it in Go, and I don't know Go, F#. Like, why didn't they just Bash or whatever? It doesn't work on my machine. I'm not sure how to update it, so it's a bit painful. Maybe they're using, dev containers, spaces. That would be freaking. I can just load it in VS Code or Rider, get up and running, and everything's wired up for me. Except if, like, I'm a new developer, I'm junior. I don't know that JSON file in order for it to work, and I don't know to know all these different tools in order to sometimes. And maybe I don't know how to do it. Maybe I'm on Apple. My friend who I work with is on an Intel machine. Is the image that I'm choosing going to work for me and not for him, or vice versa? Hopefully not. So this is where I think .NET Aspire kind of peaks, because you're able to get that great experience because it's all codified. It's in compiled code. I can read it fairly easily. Hopefully, C#'s easy for you as well. I find it, it's quite good, and I'm able to get things up and running quickly. I don't need to worry about installing that many dependencies on my machine. So it's kind of the best of both worlds. I can still use this with code spaces and whatnot, which is freaking awesome. So thank you. If you leave with one thing today, use .NET Aspire. It'll change your world. Thanks. Cool. So anyone got any questions? You all love it. Where do I start? Well, I told you that it was that .NET workload install Aspire. Yeah.
Does it create your database? Oh, sorry. When you did all that setup, did it create your database classes for you, or was that already set up?
No. So that so on there, I added in the Postgres server and a Postgres database, and Aspire knew how to go in, spin up the database, spin up the server, add the database in, and then grab the connection string out of it so it could be reused. And then when I stopped, it tore it all down for me. Except if you bind the data volume, and then it gets persisted in between starts. But still, the server starts up. It sees the configuration there, so it knows, hey, I'm just going to load that up and run with it. No other questions? Awesome. All right. Well, thank you, everyone. Have a good night.